So here's 22. Now this one, the rewrite step is actually going to take us a little bit of work. So I have limit as x approaches 0, 1 over 2 plus x minus 1/2 over x. It looks sort of complicated, but if you remember from your Algebra 2 and Pre-Calc, how do I simplify a compound rational expression? I multiply the top and bottom by the least common multiple of the extra denominators. So my extra denominators in here are 2 plus x and 2, so I'm going to multiply the top by 2 times 2 plus x and the bottom times 2 plus x. And if you didn't know that or think of that, that's probably okay. That's one that we don't do a whole lot of in some of our earlier courses, but if you don't know, now you know. So you can multiply the top and bottom by the least common multiple of the extra denominators. All right, so when you do that, the 2 plus x, so you're going to think of the 2 over 2 times 2 plus x as distributing on these two terms. The 2 plus x and the 2 plus x will cancel in the first multiplication, so we just have 2 times 1, which is 2, and then I have the 2 times 2 plus x times 1/2. In this multiplication, the 2's cancel, but the 2 plus x stays, but I have a minus in front of it, so it's imperative that I do not forget the parentheses around 2 plus x. This is minus 2 plus x. That minus is going to distribute. In the denominator, I have x times 2 plus x, so let's just rewrite that in sort of a convenient way, 2x times 2 plus x, and now I've committed a grievous error that hopefully you noticed, which is that I forgot to write the limit statement. Limit as x approaches 0. That's like the cardinal sin, doing limits. All right, because I'm not to this substitute step, so I have to keep that limit statement on, and I forgot to write it. All right, but now I've got it. So now, I'm still in the rewrites phase because I'm not really at a point where I can factor it yet. So I'm going to go limit as x approaches 0. I'm not going to forget that this time. 2 minus 2 is 0, but then I'm going to have negative x in the numerator. And the denominator, if I want, I can FOIL that out and distribute that out and get 4x plus 2x squared. All right, and then now I've got something I can factor, right? Because I can factor the denominator. So now I'm finished my rewriting. I've rewritten it to a point where I can factor it. Now I'm going to factor it by factoring the denominator, negative x. And then I realized, by the way, that it was kind of dumb of me to distribute this out since I'm just going to factor it back out anyway. But hey. Also, I'm going to factor it slightly differently. Since I know that the x is going to reduce with x and not 2x, I'm not going to factor the 2x out. I'm just going to factor the x out. And then I'll have 4 plus 2x. Of course, you can factor the 2x out. You'll get the same result. But I'm just doing this because these x's will cancel and then I don't have a 2 outside and have to distribute it again. All right, so that's that. It's still a limit. I've now factored it. I've done this, so I'm ready to do this. Simplify. My matching factor is x. So now I'm still going to have a limit as x approaches 0. I have negative 1 over 4 plus 2x because the x's have reduced out. That's my simplify step. Now I'm ready to substitute, and when I substitute, I'm going to drop the limit statement. So now I'm going to have negative 1 over 4 plus 2 times 0. And that equals negative 1/4. All right. Could I have just said when I plug in the 0, I get negative 1/4? Yes, but it's nice for me to show that where that negative 1/4 came from is I plugged the 0 in for the 2x. So I'm just showing that. All right. So notice that the limit statement dropped here. Remember, you're going to be graded on your writing where you have to show this is a limit, limit, not a limit. So if you say this is a limit when it's not, you're going to lose points in some contexts. If you don't say this is a limit when it is, you're going to lose points, in certain assessments. All right. Now, your book, of course, just says the answer is 1/4. But look, this is what I'm really interested in seeing. I don't care that it was negative 1/4. You could have copied the negative 1/4, but you can't copy this. You need to come up with that. And you might even be developing your own mathematical style at this point that's sort of recognizable. All right. So basically, you've now seen 3 examples of evaluating a rational limit at a real number. Rational, real number. You rewrite, factor, simplify, substitute, remembering that sometimes you don't have to rewrite. We didn't have to rewrite this one. And remembering that substitute is the step where you drop the limit. Next, we will look at some limits involving sign.